Hello everyone, myself Dr. Kabita Sarkar, Associate Professor, Department of Mathematics, Swami Vivekananda Institute of Science and Technology, Kolkata 145. In this lecture, I am going to discuss on linearly dependent vectors and linearly independent vectors. What are linearly dependent vectors? A finite set of vectors alpha 1, alpha 2 to alpha n of a vector space Vf is said to be linearly dependent, shortly LD, if there exists a set of scalars a1, a2 to an, not all 0, though some may be 0, such that a1 alpha 1 plus a2 alpha 2 up to an alpha n equals to 0. And this 0 is the 0 vector. What are linearly independent vectors? A finite set of vectors alpha 1, alpha 2 up to alpha n of a vector space Vf is said to be linearly independent, shortly Li, if there exists a set of scalars a1, a2 to an, all of them are 0, such that a1 alpha 1 plus a2 alpha 2 up to an alpha n equals to 0 vector. Question number 1. Find if the following set is linearly dependent or independent. 2i, 3j, 5i minus 12k, I plus j plus k. 2i, 3j, 5i minus 12k, I plus j plus k can be written as 2i plus 0j plus 0k. 0i plus 3j plus 0k, 5i plus 0j minus 12k, I plus j plus k. Let us take the vectors as alpha 1, alpha 2, alpha 3 and alpha 4. So alpha 1 becomes 2, 0, 0, alpha 2, 0, 3, 0, alpha 3, 5, 0, minus 12, alpha 4, 1, 1, 1. Let there be scalars a1, a2, a3, a4 belonging to R such that a1 alpha 1 plus a2 alpha 2 plus a3 alpha 3 plus a4 alpha 4 equals to 0 vector. Now let us put all the vectors alpha 1, alpha 2, alpha 3, alpha 4, and the right hand side becomes 0 vector, the component 0, 0, 0. Now let us compare left hand side and right hand side. So here left hand side 2a1 plus 0a2 plus 5a3 plus a4. So we are getting the first equation as 1, 2a1 plus 5a3 plus a4 equals to 0. Next is 0a1, 3a2, 0a3, a4, 1. So we are getting 3a2 plus a4 equal 0. Equation 2. Next, 0a1, 0a2, minus 12a3 and a4. So the third equation we are getting is minus 12a3 plus a4 equals to 0. Now from equation 2 and 3, a4 will be cancelled if we subtract. Then we will get 3a2 as 12a3. So from here we are getting a2 as 4a3. Now let us take a3 as free variable and suppose that a3 is k. Then a2 will be 4k, a4 will be minus 12k. Look here, A4 is 12, A3 is K, so A4 is minus 12K. And A1 will be 7K by 2. Check here, A1, from here A1, 2A1 plus 5A3 plus A4. If you put A3 and A4, then you will get A1 as 7K by 2. All the scalars here non-zero, so the vectors are linearly dependent. We can solve that sum in different way by operating the augmented matrix. Here the system of equations let us form in augmented matrix, where A is 2, 0, 0, 0, 3, 0, 5, 0 minus 12 and 1, 1, 1. X, A1, A2, A3, A4 and B 0, 0, 0. Now let us take the augmented matrix, that is A, B together, and do some row operations. So here R2 dash is R2 minus R3, R2 minus R3, and R3 dash R1 minus R3, R1 minus R3. Now another operation we have done, R2 dash R2 by 4. So by this operation we have got the latest matrix, where the third equation we are getting as A3 minus 1 by 12 A4 equals to 0. Let us take A4 as free variable, A4 as K, then A3 will be K by 12. From second row we are getting A2 plus 4A3 as 0. There let us put the value of A3. We are getting A2 as minus K by 3. From the first row we are getting A1 plus 5 by 2 A2 as 0. So A1 is 5K by 6. Similarly, all the scalars are non-zero, therefore the vectors are linearly dependent. Recall the memoirs of few solutions of system of linear simultaneous equation x equals to b. There are three possibilities. Number 1, no solution. Number 2, infinitely many solutions. Number 3, unique solutions. In number 2, infinitely many solutions, there may be three options. 1, more unknowns than equations. Number 2, missing variable. Number 3, 0 equations. So in the above question, there is no unique solution in general. So there is infinitely many possible solutions, and existence of infinitely many solutions for option 1, more unknowns than equations. Look here. Unknowns are 4, equations are 3. There are 3 equations and unknowns are A1, A2, A3, A4. 4 unknowns. Okay. Now say test for linear dependence and independence depending on these solutions. If a system of linear equation Ax equals to b has one solution, then the column vectors of A must be linearly independent. If the system has infinitely many solutions, then the column vectors of A must be linearly independent. If such a system has no solution, we don't know whether or not the column vectors are independent. We do know, however, that B is not a linear combination of the column vectors. Okay, so applying that, here we see the latest matrix is here. So from here we can uh, find the rank of the augmented matrix and the matrix A. Here we see the rank of the matrix is 3 and rank of the augmented matrix is also 3, which is less than the number of unknowns. So according to it, that if the system has infinitely many solutions, then the column vectors of A must be linearly dependent. So we know that we have seen this one. Here you see that the possibilities are 3, infinitely many solutions, more unknown than equations. So here we see that the unknowns are 4 and which is more than the number of equations. Therefore, the vectors are linearly dependent. Next question, find if the following set is linearly dependent or independent. 1 0 0 0, 0 1 1 0, minus 4 6 6 0. Let us take the vectors as alpha 1, alpha 2, alpha 3, and let us take the scalars a1, a2, a3 belonging to R such that this linear combination holds. And let us put the vectors. Then comparing, we are getting 3 equations. And look here, equation 2 and 3 are identical. Now similarly, like question number 1, you can find the values of the scalars in terms of k, where here a3 has been taken as free variable and we are getting all of them non-trivial, therefore they are linearly dependent. Similarly, like question number 1, we can solve question number 2 by the alternative way. Here the augmented matrix, and look, two rows are identical. So doing some row operations, we have got this one where two rows are identical, taking as 0 0 0 0 0 0 all those components. So from here we can get two equations, and these equations are same as before. So we can solve them taking free variables. In terms of free variable, we will get the other values. You can do it yourself. Alternative way, the second alternative way, that the number of unknowns are 3 and the rank of the matrix is 2 and rank of the augmented matrix is also 2, which is less than the number of unknowns. Therefore, applying these infinitely many solutions where more unknowns than equations, the vectors are linearly dependent. Here two questions are given. Find if the following set is linearly dependent or independent of these set of vectors. Solve yourself. Thanks for watching this lecture. Get a free certificate course in SVIST CLMS domain. You will find other engineering mathematical topics in this YouTube channel. Multivariate integration lecture series, probability lecture series, probability gate question answer, graph theory gate question answer, linear algebra gate question answer, numerical analysis, discrete mathematics, complex analysis, partial differential equation. All the best.
For admission and course-related enquiry, please visit college website http://www.svist.org/